Good morning, dear student. In today's lecture, we are very much interested in the important topic of our chapter, that is the properties of superconductor. So, we already discussed the definitions, the effect of magnetic field, then all the important points of this chapter. So, let us discuss some important properties of this superconductor. Whatever the current which is flowing in the superconductor, it is persists for very long time. So this is the important property of superconductor, that is whatever the current in the superconductor, in the superconductor current in the superconductor persist persist for persists for very long time. So this is the first property of this superconducting material. Whatever the current which is flowing in the superconducting material, it is persists for very long times. Second, that the superconductivity occur in metals having high normal resistivity. So this superconductivity occur in metals occur in metals having having high normal resistivity. High normal resistivity. High normal resistivity. So this is the second important property of superconducting material. The first one is the current in the superconductor persists for very long times. Second, the superconductivity occur in metals having high normal resistivity. So we already discussed the terms resistivity, conductivity, and all of this. Generally, the monovalent metals are generally not a superconductor, but monovalent metals are generally not a superconductor, but bismuth, antimony, and tellurium becomes superconducting under high pressure. Or we can say that the monovalent metals are generally not superconductor. So monovalent metal, monovalent metal are generally not superconductor. Are generally not act as a superconductor. Not a superconductor. Monovalent metals such as sodium, potassium is there. For example, sodium, potassium is there. So this is also the important properties of superconducting materials. So monovalent metals are generally not act as a superconductor. Again, the next one is that, but the bismuth, antimony, and tellurium becomes superconducting under high pressure. So the example is bismuth, antimony, that is Sb, and tellurium. Bismuth, antimony, and tellurium are superconductor superconductor at high pressure. At high pressure. At high pressure. Again, the next important properties of the superconducting material, we already discussed it in our previous lecture, that is diamagnetism is an essential properties of superconductor. So superconducting material shows diamagnetism. 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 Diamagnetism is an essential property. Is an essential property. Essential property of superconductor. of superconductor. So we know that at below Tc, at below critical temperature, the superconducting material, it is act as a perfectly diamagnetic material, and therefore diamagnetism is an essential properties of a superconductor. So uh, so these are the some properties. Current in the superconducting material persists for longer time. Superconductivity occur in metals having high normal resistivity. Generally, the monovalent metals are not act as a superconductor. And then the bismuth, antimony, tellurium, they will show superconductivity at a high pressure, and diamagnetism is an essential properties of superconductor. Let us discuss some another important properties of this superconducting material. Another important properties of this superconducting material. The next one is that next important properties is that uh, critical temperature of a superconductor varies inversely with isotopic mass. Critical temperature, that is Tc, critical temperature of a superconductor critical temperature of a superconductor, uh, it is varies. Critical temperature of superconductor inversely varies inversely varies inversely with isotopic mass. Isotopic mass. So there is an inverse relationship between the critical temperature of superconductor and the isotopic mass. And the critical temperature of superconductor, it is inversely proportional to the isotopic mass. So we can say that as isotopic mass is increases, and then the critical temperature is decreases because it is inversely proportional. So critical temperature of superconductor varies inversely with isotopic mass. Let us discuss the next important properties of the superconducting material, that is at transition. At transition, all magnetic flux is ejected out by superconductor, and below as that is at a transition, all magnetic flux is ejected out by superconductor and behave as a diamagnetic material. So this is all about, we already discussed, that is the diamagnetism is an essential properties of superconductor. At a transition means that is conversion of normal conductor into superconducting state. So at a transition, all magnetic flux is ejected out by superconductor and behave as a perfectly diamagnetic. So this is also important point, that is at transition. At transition means there is a conversion of normal conductor into superconducting state. At a transition, all magnetic lines of force, all magnetic lines of force or magnetic flux, all magnetic flux is ejected, it is removed, it is ejected, it is ejected out by the superconducting material, by superconductor, and and behave as a diamagnetic material, and behave as behaves as a diamagnetic material, and behave as a diamagnetic material. So this is also the important point. So we already discussed, that is the diamagnetism is an essential properties of superconductor. But how this diamagnetism is occur in superconducting material, that is at a transition, all magnetic flux is ejected by the superconducting material and it behaves as a diamagnetic material. For superconducting material, the flux density, that is B, is equal to 0. This is also the important point, that is for superconductor, for superconductor for superconductor, the flux density B, capital B, it is equal to 0. Again, this is also the important point for superconductor. The flux density, magnetic flux density or magnetic lines of force is nearly equal to 0. Then the next important point is that all thermoelectric effects disappear in the superconducting state. That is, we know that because in superconducting state the material it will shows perfectly diamagnetism, and therefore all thermoelectric effects disappear. All thermoelectric effects, all thermoelectric effects, all thermoelectric effects disappear. All thermoelectric effects disappear in the superconducting state. In the superconducting state. This is also the important properties of superconducting material, superconducting state. So all other effects, thermoelectric effects, are disappear in the superconducting state. Let us discuss some other important properties of this superconducting material. That is, a superconductivity does not occur in the noble metals. So this is also the important point. Superconductivity superconductivity does not occur in noble metals. In noble metals. In noble metals like gold, Au, silver, Ag, and also and in most of ferromagnetic metals. Ferromagnetic metals. So superconductivity does not occur in noble metals like gold, then silver, and in most of the ferromagnetic metals. Again, most of the physical properties of the superconductor vary from material to material. The next important point is that is most of the physical properties, of superconductor vary from material to material. Vary from material to material. Vary from material to material. For example, heat capacity and critical temperature. For example, which property? That is the heat capacity and the critical temperature. Because we already discussed the important properties that the critical temperature is inversely proportional to the isotopic mass. So material to material, these properties maybe change. So this is all about the properties of superconductor. In next lecture we will discuss the remaining points of this chapter. Thank you.